Hello all. We're back now for a quick review of Chapter 6, which is the geometry chapter in your Level 7 math book. As we move through this, I just wanted to make sure I pointed out that the notepad icon will appear on just about all of the slides. The reason being is that these should be things that are in your notebook already. If they're not, you need to write them down. If they already are, then you should just keep them in there and you don't need to write them a second time. So our basic vocabulary to start with this chapter is you should know the difference between an acute angle, a right angle, an obtuse angle, and a straight angle, especially in dealing with the right angles and the straight angles, which add exactly to 90 degrees and exactly to 180 degrees. That becomes an important part in this unit as we go forward in solving for various angles that add to right and straight angles. Angle measure, like I was saying, is a very important part of this section. Supplementary angles form a straight angle, which is 180 degrees, and complementary angles form right angles. A typical type of problem that you might come across with this piece is to solve for an angle measure when you're given a straight angle and you know the approximate values of each of the angles. So as you can see in this one, our smaller angle has a value of x minus 10 degrees, and our larger angle has a value of 2x plus 10 degrees. What you want to do to solve these is set yourself up a nice equation that shows that when you add the two angles together, you get 180 degrees. Now, in solving that, that glare just makes me crazy. In solving that, what we want to do is combine our like terms. We can add our x and our 2x together and get 3x. Oops, a little typo right there. Did you see that? That should be an x minus 10 copied down from there. So then I can also combine my 10s, and I have negative 10 plus 10, which is going to equal out to 0. So negative 10 plus 10 will equal 0, so I can write my 0 in there if I want. I can also leave it out. And that's going to equal 180. Now if you notice on here, I have 3x equals 180. To solve for x, I need to use my opposite rule. So this is multiplied 3 times x. So I want to divide both of those sides by 3, which is the opposite. So I'll go ahead and make my 3's cancel out. And then 180 divided by 3 is 60. Now, a lot of students think at this point that they're finished with the problem, but you actually aren't, because you haven't told me the measure of each of these two angles. So what I need to do now is take my 60 and substitute it back in up here for the x. So there I'll have x minus 10. I substitute 60 for x. So 60 minus 10 is not barely on the screen. There it is. Gives me 50. So this angle here is 50 degrees. And then on the other one I want to do the same. I'm going to take 2 times my 60. Remember, I got the 60 from down here as the value of x, and add 10. Multiplication first, so 2 times 60 is 120, plus 10 will give me 130. Now, I know a lot of you will tell me when you get to this step, well, if I know this angle is 50, this one has to be 130 because they add to 180. And you're absolutely right. You could have solved it that way too. You can do the same process and solve for right angles, except they'll add to 90 degrees instead of 180. The next area that we want to cover is the concept of vertical angles. Vertical angles are formed when two lines intersect. If you can tell the lines need to be straight, you can tell these are not vertical angles because the line is bent on that side. When you have vertical angles or two straight lines that intersect, these angles, like A and B, form what we call vertical angles, and the great thing about them is their measures are equal. So if one is 46 degrees, then the other is 46 degrees. Now that makes it really easy to solve situations like this one, which gives us the setup for the vertical angles and then the measure of each of them. In this one, you'll notice it tells us that the measure of angle 2 is 115 degrees. Once we know that, we can find the measure of angle 4 because those two angles are vertical, so they must have the same measure. Now once we know the angle of, or the measure of angle 2 and the measure of angle 4, it's pretty simple to solve for either 1 or 3. If you notice here, this line makes a straight line. We know that a straight line or a straight angle equals 180 degrees. So when we're solving for this one, we know that if we take the measure of angle 3, I'll call it x, and add it to 115, we get 180. So we can solve that equation easily by turning around and subtracting 115 from both sides. And once we do that, oops, I should write it like that a little bit better, we figure out that our measure of that angle should be 65 degrees. Because 65 plus 115 will give us 180. Now once we know that angle 3 is 65 degrees, angle 1 is vertical with that angle, so it also has to be 65 degrees. So we went through really quickly and were able to find the measures of all 4 of those angles. Okay guys, we can go on next to our next formula, which is the area of a parallelogram. You should remember that the area of a parallelogram is the base times the height. And most important in this one is to make sure that you're using the actual height of the parallelogram, not the length of the second side. So you want to make sure you have the height times the base. So you can see in our sample problem here, we need to find the area of this parallelogram, which we know is the base times the height. So our base is 2, and our height is 3. Again, make sure that you use the height of 3, not the slant height or the side length of 5. So 2 times 3 is 6. So this parallelogram has a simple area of 6. And on the next one, sorry about that little bubble, we want to look at the area of a triangle, which is very similar to the area of a parallelogram. Again, we're looking for the base times the height, but this time for a triangle we need to take that and divide it in half or multiply it by 1/2. It's the same mathematical option, either dividing by 2 or multiplying by 1/2. I also want to make sure that you realize, just like in the parallelogram, we need to make sure that we have the actual height. Oopsie, let's try that again. The actual height of the triangle, not the slant height or the length of a side. When we're looking at this triangle, you can see that it has a base of 5, a side height of 4, a side height of 6, and then an actual height of 3. So we want to take our formula again, which is area equals 1/2 the base times the height. We want to plug that in and solve it. So 1/2 of 5 times 3, which should give us 1/2 times 15. And 15 divided by 2, or 1/2 of 15, is 7.5. So this triangle has an area of 7.5. Our next one looks at the formula for an area of a trapezoid. Now I hadn't reviewed earlier, but I'll make sure you guys realize now that a trapezoid is a figure that has 2 parallel sides and 2 non-parallel sides. So a trapezoid has 1 set of parallel sides. In finding the area of that, we take the base plus the other base and divide it by 2. Essentially what we're doing there is we're finding the average of the 2 bases, and then we're multiplying that by the height. Again, make sure that you have the height, not the side length or the slant length of the trapezoid. You guys can see my adorable little trapezoid here. When I'm looking for this, again, remember the area formula is area equals the first base plus the second base divided by 2 times the height. So I'm going to go ahead and fill this in. When I'm choosing, my first base is 10, my second base is 20, my height is 10, my slant height is 18, but I don't use that to factor any part of my equation. So I'm going to have 10 plus 20 divided in half times 10. So 10 plus 20 would give me 30. Divided in half, not 3. So that gives me 30 divided by 2 times 10. So 30 divided by 2 is 15 times 10 will give me 150 for my area. Hopefully that's squeezed in right there on the bottom. Yep, you guys can see it. So my area for this trapezoid is 150. Next, we're going to go on and look at some circles. Remember, in these two, we had the circumference of a circle as one formula. So we took the radius and multiplied it by 2, and then multiplied that answer by pi. When we wanted an exact answer, we left it in terms of pi, and when we wanted a rounded answer, we replaced pi with 3.14 and solved. We could also, instead of the radius times 2, we also knew that we could take the diameter of the circle times pi itself and solve for it. Next, you can see our formula for area. Area again uses the radius of the circle, but the formula is the radius squared times pi to get the area. And in these situations, if we're given the diameter instead of the radius, remember we can take that diameter divided by 2 and it will give us the radius. So let's try and solve a couple problems here on circles. So my first one here, you can see I have a nice little circle with a radius of 5. To find the circumference of that, remember I'm going to take pi times the diameter. Well, in order to solve the diameter of this circle, I need to find the distance all the way across, which is double the radius. So this diameter here would be 10 times pi. Now if I wanted an exact answer, I would leave it as 10 pi. If I wanted an approximate answer, I would replace pi with 3.14 and multiply. So 3.14 times 10 will be 31.4. This is my exact answer. This is my approximate answer. If I wanted to take the same circle now and solve for its area, I could take here and use my formula. Area is pi times the radius squared. So I'm going to fill in pi, and then 5 is my radius squared. Remember, squared means you multiply the number times itself, which gives me pi. 5 times 5 is 25. So the exact area for this circle would be 25 pi. If I wanted an approximate number, I would replace the replace the pi with 3.14, and then I would get an approximate value, and I would round it to the correct number of digits that I was told. So you guys can see here on my calculator, I'm going to go ahead and take 25 times 3.14, and that'll give me 78.5. Now some students also like to use the pi button, so they could use 25 pi, and you'll see they get 78.53, and they would need to round from there. Remember again, the exact answer is in terms of pi, and the approximate answer is rounded with pi replaced as 3.14. That brings us to one quick reminder about, again, the pi versus pi as an exact answer versus an approximate answer, which I gave you a couple examples there. That brings us then to the end of our test, as always, or the end of our review. You should be ready for the test. You need to complete your entrance ticket, and then once you have that finished, you can turn it in, have it scored, and then you're able to take your test. There's a math joke to finish out your day, and if you guys have questions, just let me know.